Hey, how's it going everybody? And welcome back to Michael Workspace. I am Michael, and in today's lesson, we'll be tackling another coding interview question called Increment and Arbitrary-Precision Integer. And the problem statement goes like this. Write a program which takes and input a list of digits encoded to a non-negative decimal integer d and update the list to represent the integer d plus 1. So for example, if the input is 129, then you should update the list to return 130 because 130 or 130 is one more than 129. So how can we approach this question? Well, one naive approach is basically to convert our digits, array of digits, to an integer, update that, increment that integer, and then return that back to a list of digits. And how we can code this up is by we'll begin by creating a function called +1. And I'll just say naive because we'll come up with a better solution after this. You'll take a array as an input, which is a list of int, and then return a list of int. And then we can begin by initializing a variable called temp to a string. We'll join that to the map function, which takes in a string function and our array. Then we want to increment this by first converting it back to a integer and incrementing it. Then we want to initialize an empty list to store our results, and we can begin our loop. Since temp is right now a integer, we need to convert it back to a string so that we can iterate through it. And then we append it into an answer empty list right now for our results. But then we convert it back to an integer to store each item as an integer instead of a string. Finally, we return answer. Let's test this out. We're going to go ahead and use our example from above in a problem statement of 129. And we'll save our results and run the program. And we got back 130. Let's go ahead and try another example here where we'll use a case where it won't have any carry, so like 122, and we expect our result to return 123. Let's save this and run the program, and we got back 123. So this solution works. However, it is not the best since you're seeing we're doing a lot of different data type conversions, and we also run into the problem where if you're using a programming language where when you're converting a arbitrary number of digits from a array of lists or array, and it exceed the limitation of what an integer bucket can hold as how many digits, then you run into something called overflow. How we can better handle this is something that we learned in grade school, where when we do addition, if we work with the least significant digits so let's go back to this example here, 129. When we add to this 129 number, we add starting from the least significant digits, which is in the ones position. If it goes beyond 10, then we carry over the 1 and propagate down until there's no longer any carries, and that will give us our results. So if we were to add 1 to 129 here, this becomes 10, but instead of 10, we leave it at 0 and carry over the 1. So now 2 become 3, and that should be it. So let's code this up. We define our functions called +1, takes in the same inputs, and return a list of ints. Since we're going to be incrementing from the last digits, we're going to go ahead and increment the last item in our array and begin our for loop. we're doing reverse, and we're starting at 1 so that we don't have to, we already handle our beginning case where we update the last digit by incrementing by 1, and now we're reversing our list and excluding that first item or last item, and so that we can work with each iteration. So if a sub I does not equal 10, then we want to break. Otherwise, we update a sub I to be 0, and then we increment the next least significant digits to be increment that by 1. Finally, now we're out of the for loop. If a sub 0 equals 10, then what do? Well, if a sub 0 is equal to 10, that means that we need to carry out we need to carry out the 1 digits. And then how do we handle this? Well, a cool case or a slick way of doing this is just by changing the a sub 0 or the first item in the element in the array to be 1, and then just appending 0 to the end of our array, and that will give us our answer. So we'll update the first element to just be 1, and then we append 0 to the end of our array, and then we return our array. Let's go ahead and test this out, see if it works. Using the same problem as above. Save it and run the program, and we got back 130. Okay, looks like this works, and the time complexity for this solution is going to be linear, and the space complexity is going to be constant. Alright guys, hope you guys like what you guys are seeing. If you do, please give the video a like and subscribe to my channel if you haven't already done so. I'll be putting out more content like this in the future. Alright, have a good one. I'll see you later.